I'm going to quick show you a new derivative rule. It's popping up on the homework. We got to see it. It's just a rule that we've got to know. So we already know the derivative of e to the x is e to the x. If we incorporate the chain rule, we know that the derivative of x of e to the u is e to the u times the derivative of u, whatever that function is that's been plugged in. E is a number, right? E is just a number, 2.71828, all that good stuff, right? Well, what happens if E is a different number? For example, what happens if I'm taking the derivative of 2 to the x? The derivative of 2 to the x is 2 to the x itself, but then I'm going to multiply by the natural log of 2. Okay? I could go into some rules as to why that works, but we haven't learned some of the derivatives that would help me explain that the best. So we're just going to have to take this right now as that's a rule I got to know. So this rule, the derivative of a to the x, where a is greater than 1. Technically, it's just not 0, it's not 1, but here we go. The derivative of a to the x is a to the x times the natural log of a, like we see here with 2. But if we were to incorporate the chain rule, a to the u, so a to a function, then it's just going to be a to the u times the natural log of a times the derivative of u. So let me give you an example of that. Again, this is just a rule I need you to know. One or the other, as long as you understand chain rule, you should be set up, but you got to know this rule. So if we were to take the derivative of 7 to the x cubed, the derivative of 7 to the x cubed is 7 to the x cubed times the natural log of 7 times 3x squared. 3x squared comes from the derivative of x cubed. Okay, short and sweet. Hope that helps. If you got questions, you know where to find me.